You can take an entire course including topics in this video through our website and get a certificate of completion from RASOF, the online educational radio frequency institute located in Irvine, California. Instructions and coupon for taking this course is provided at the end of this video. In this section we are going to talk about RF module, transmitter, receiver, and transceiver. RF module. An RF module is a small electronic circuit which is used to receive, transmit, or transceive radio waves. So RF module is a block and it has lots of sub-blocks and circuits inside it. So we construct this block, we use it for receive data, for receive actually radio frequency waves, or transmit them, or we say transceive them. It means that we send and receive them. So when we say transceive, it means both together, sending and receiving. So we say radio waves on one of a number of carrier frequencies. So it means that these radio waves has a high frequency. When we say carrier frequency, it's a high frequency. We will talk about carrier frequency and also oscillator and this kind of things. An RF module is a functional integration of semiconductor devices. So we have lots of RF module examples like VLAN, Zigbee, Bluetooth, GPS. All of these applications have their own RF module, own circuitry. So as you see in this picture, this is a transceiver module. It's a HC06 Bluetooth RF transceiver module. As you see here, for example, you can see there are components here. Passive components, like as you see, these are capacitance, resistance, and we have a IC here, and this part is the antenna, as you see. And there's another one, we say remote control based. It's working on 433 megahertz. This is the carrier frequency. It means that when we talk about the carrier frequency, we modulate our data, and we actually talked about the frequency shift. So we are trying to shift the frequency of data to this frequency, and it means that we are sending out the radio frequency waves at this frequency, 433 megahertz. When you see these numbers, it means that this is the carrier frequency of this transceiver. But this one, as you see, it's a separate. So this part is the transmitter and this part is a receiver. It's two parts, and we call both of them modules. So this is a transmitter module, TX module, and this is a receiver module. And as you see these numbers, this is the carrier frequency. It means that the waves are being sent out with this frequency. You can see for example, the range here as well. It's not only 433 is the maximum. So it means that this is a kind of a band, the receiving band of this module. And this is 2.4 GFSK transceiver. These are related to modulation. When we say GFSK, FSK, these things, we are going to talk about this. We will have course for modulation. We don't have to worry about it. This is just an overview. As you see, there are lots of blocks inside our module. For example, antenna matching, transceiver, receiver, they're all together. As you see, there are lots of blocks inside this module. Antenna, receiver, transmitter, as you see, the digital part, analog part, and as you see, this is the thing. We have the antenna in this part, some components, IC. You can see lots of blocks inside this module. Let's talk about transmitter. A transmitter is an electronic device which produces radio waves with the help of an antenna. So basically, transmitter is a block, and it's connected to antenna, and so it sends out, for example, let's say a transmitter generates a radio frequency current, and it gives it to the antenna, and after that antenna radiates and produces radio frequency waves. Transmitter generates radio waves for communication, radar, and navigational purpose. The transmitter can either be separate pieces of electronic equipment or an integrated circuit, which is called IC, within another electronic device. So transmitter transmits lots of data, for example, data from microphone in mobile, TV data, camera, digital signal, and everything. So we say the transmitter combines the information signal that is to be carried with the RF signal which generates the radio waves. And we call this carrier. We're going to talk about this. So actually we have a data in transmitter. We talked this before. This data has a low frequency. So we say low frequency data. And inside this transmitter we have a carrier. So basically the frequency of this carrier is high, so we say this is high frequency. We use this carrier to translate data to high frequency. That's why we say is to be carried with the RF signal which generates the radio waves. So this carrier has a high frequency, we do modulation, we do frequency shift and translate the data channel to the high frequency, then we send it to the antenna to be emitted to the environment. What about the receiver? A radio receiver is a device that receives radio waves and converts the information which is carried by them into usable form. So when we say a usable form, it means that we receive high frequency signal, but our data is kind of buried inside this high frequency signal. So we have to separate it. We have to do demodulation and restore our data. For example, if we are sending a voice, the voice has a low frequency, but we combined it with the carrier. So if we get it and just listen to it, we won't get anything. So we have to do demodulation. We have to separate the high frequency part and get our voice from it, get our sound. So we say a radio receiver can be again an integrated circuit within another device. Antenna intercepts electromagnetic radio waves and then converts them into alternating currents that are applied to receiver. Exactly opposite of the transmitter. This time this antenna intercepts the waves and it converts it to current. So we get this is RX. So we get it and do process demodulation and everything inside the receiver. We separate the part, separate the usable data, and generally it's like this. So in this picture we can see the very simple view of transmitter and receiver. We can see some building blocks. For example, for a receiver, we receive data, there is a filter, low noise amplifier, then we mix it, bandpass filter, then it goes to the digital part. So actually this part is a kind of digital. And vice versa, here in the transmitter we have digital part, we convert it to the analog, and here as you see again we have a mixer, local oscillator, bandpass filter, power amplifier. We amplify the signal and we send it to the antenna. We are going to talk about these blocks in upcoming courses. We will have course for LNA, we will have course for power amplifier, we will have a course for the transmitter and receiver architecture. So as you see, this architecture here is a very basic architecture, but you will see that we have complicated architectures. We will talk about all problems, drawbacks, advantages that we face in designing a receiver and transmitter. So this is just the overview, a summary, and it's a very simple structure. So as you see that there are common blocks, there are blocks inside the receiver and transmitter that we use all the time. The mixer, local oscillator, LNA, filters, and power amplifier. These are the blocks that we always have inside our receiver and transmitter. Let's talk about the front end, which is really important. You can see the word the word of front end, we call it, sometimes you can see FE, and many people ask about this. So we say in a radio receiver circuit, the RF front end is a generic term for all the circuitry between the antenna up to and including the mixer stage. So as you see in this picture, these red blocks are all front end. So it starts from antenna, filter, RF amplifier, and goes up to the mixer. After this, we actually translated our data to low or maybe intermediate frequency. So after this, it will go to intermediate frequency, IF. But this part is RF because we have high frequency in this part, and it's really challenging and important, the most important part of our receiver. So we call this part front end. It consists of all components in the receiver that process the signal at the original incoming radio frequency. So this part is operating at radio frequency, and after mixer we have intermediate and sometimes very low frequency. So we don't call this RF. Basically, we don't have any RF part here. We don't have any radio frequency. So we only have radio frequency for this part. That's why we call this part front end. And we say original incoming radio RF before it is converted to a lower intermediate frequency. So here, as you see, this part is a low frequency, or we can say intermediate frequency. So this is the definition of front end. Hey guys, thank you for watching the entire video. I'm going to provide you with a coupon for taking RF fundamental basic concepts and components, RF 101. So you can get this course from our website. If you go to the page, you just have to select the buy this course and register here, as you see if you're not registered up to now. So you need your username, email, password, and also you have to answer a security question. And then you can press the register button, press the sign up button, and you will be able to register in our website. Then after that, all you need to do is going to the course landing page and go to checkout, and as you see, click to enter your code. You can put the coupon code here and then apply the coupon. So then you will have this course for free, and you can take this course. As you see, you won't pay anything for this course. Rasoft has one of the most complete online certificate in radio frequency available, which covers practical topics needed to be a knowledgeable RF engineer. Since all courses are consulted closely by design engineers and pioneers whom have worked as RF engineers in top RF companies such as Qualcomm, Broadcom, Skyworks, Intel, and Apple, as well as avionic companies. It covers the necessary information to land a job or successful in your career. Your first step to take the prerequisite course, RF 101, which we have provided the free coupon for it, RF PREREQ 101. See you there shortly.